Hello everyone. In this video, we're going to be dealing with a quadratic equation. We have x squared minus 5x plus k equals 0. K is a constant. And the roots of this equation are x sub 1 and x sub 2. And we're also given the relationship 4 times x sub 1 minus x sub 2 equals 10. So we're going to be looking for the k values. And I'll be presenting three methods. Even though the second method and third method are pretty close, I would still like to present them. My first method, the philosophy for my first method is no pain, no gain. So I'm going to go ahead and use the infamous quadratic formula. Yay! So if you use the quadratic formula to solve this equation, you get the following. X equals negative b plus minus the square root of b squared, which is 25, minus 4ac, which is 4k. Fairly simple, right? And then divide it by 2a. So this gives us two solutions, but we don't know which one is which. Suppose x sub 1 is equal to 5 plus square root of 25 minus 4k, and that's divided by 2, of course. And x2 is 5 minus square root of 25 minus 4k over 2. Now, we got those two roots in terms of k, and we are given a relationship, so we do know how x1 and x2 are related. Let's go ahead and plug these into the equation here. So this one and this one, we're going to substitute here. Okay, let's go ahead and do that. 4 times x1, I'm just going to multiply the numerator by 4 because they have a common denominator. I don't want to change that. So if you multiply the numerator of the x1 by 4, you get 20 plus 4 times the square root of 25 minus 4k. And then you're going to subtract x sub 2 from here. Let's go ahead and just subtract the numerator. Minus 5 plus the square root of 25 minus 4k. And all of that is going to be divided by 2. And that is going to equal 10. Because that is the equation we're given. Now, we have some like terms in the numerator. Let's go ahead and simplify this fraction. 20 minus 5 is 15. And then we have 4 times the radical plus 1 times the same radical. That is going to make 5 times that. And all of that is divided by 2, but that equals 10. So if you just cross multiply 2 times 10, you get 20. Subtract 15 from both sides. And you're going to get 5. Divide both sides by 5. You're going to get the radical equals 1. Now we have something whose square root equals 1, so that means inside the radical we have to have 1 because in real world square root of 1 equals 1. There is no other number besides 1 whose square root equals 1, right? So 25 minus 4k should equal 1. Or you can square both sides and you'll get the same thing. From here, 4k needs to be 24, and that means k equals 6. Awesome. So we found the the k value by using the quadratic formula. Now here's a good question. What happens if we switch the values of x sub 1 and x sub 2 and use them the other way around and plug it into this equation? Are we going to be finding the same same k value? So something to think about, but let me just tell you, this equation is not symmetrical. So we don't have symmetry on x sub 1 and x sub 2. Let me just tell you that, and you can definitely test for yourself and let me know how that goes. All right, let's go ahead and take a look at the second method. My second method is going to be a little different, and one of the reasons why I like this problem is, by the way, I kind of came up with this problem, so I guess you could call this homemade, but these kinds of problems are very easy to make, by the way, if you've seen especially similar ones. So what I like about this problem is the fact that it can be solved in many different ways. That's what happens with polynomials most of the time. Like if you're finding the remainder to a polynomial, or it's given and you're trying to find some unknowns, there's usually 3 or 4 different ways to do it. Anyways, so my second method is going to depend on the following. We're given that we have an equation which is x squared minus 5x plus k equals 0. And x1 and x2 are the roots, which are also called solutions, right? So if this was a quadratic, or if you were to graph it like a parabola, x sub 1 and x sub 2 would be the x-intercepts where y equals 0. Right? You could also call them zeros in that case. Anyways, so since x sub 1 and x sub 2 satisfies, or since they are roots, they will satisfy the equation, which means I can plug them in. So replace x with x1 or x sub 1, whatever you want to say. I usually like saying x1. X sub 1 squared minus 5 x sub 1 plus k equals 0. And if you plug in x sub 2, same thing happens. It's also equal to 0. So we can basically set these equal to each other because they're both equal to 0 for these particular x values. This equation is not always equal to 0, only for x1 and x2. All right, from here we get something real nice. We can put everything on the same side and pay attention to the fact that we can factor this. So let's put x sub 1 squared minus x2 squared minus 5x1 plus 5x2, and obviously the k is going to cancel out. So that's nice. And this is going to equal 0 again because we put everything on the left-hand side. But notice that x1 squared minus x2 squared is the difference of two squares, so I can write it as x1 plus x2 and x1 minus x2. And these two can be factored as negative 5 times x1 minus x2. And from here we get a common factor, which is x1 minus x2. And then we get x1 plus x2 minus 5 equals 0. So from here we get two results. One of them is x1 minus x2 equals 0, which implies that x1 equals x2. Great. So here's the thing. If that's the case, we have to go back and check our work. Is this always true? Right? Because it may not be. So let's go ahead and plug it in. We are given x squared minus 5x plus k equals 0. And 4x1 minus x2 is equal to 10. Since x1 is the same as x2, you can basically replace x1 with x2, and that's going to give you 3x2 equals 10, which means x2 equals 10 thirds. But that's going to be the same thing as x1. So in this case, we have both roots equal to 10 thirds, but is that possible? And my answer to that question is no, it's not possible. Because if 10 thirds and 10 thirds are the roots, then we should be able to write this equation as x minus 10 thirds times x minus 10 thirds equals 0. But when you distribute, you're going to get x squared minus 20 thirds x plus 100 over 9 equals 0, which is definitely very different from our original equation. So this is not going to work. x1 equals x2 should be rejected. That's not the case. So the given conditions eliminate that. So we're going to have to look at the second condition, which is x1 plus x2 minus 5 equals 0. And what is that supposed to mean? It means x1 plus x2 is equal to 5. This is awesome because we also have another relationship, which is equal to 10. Now by adding these two equations, you get 5x1 equals 15 and x1 equals 3. Now if you plug it into the original equation, you're going to get the k value. Let's go ahead and plug in 3. We get 9 minus 15 plus k equals 0. From here we get k equals 6 again. Now let's go ahead and quickly take a look at the third method. And third method, like I said earlier, is very similar to the second method because we're going to arrive at the same thing. But it's much faster because we're going to use Vieta's formulas. And I believe in the community post I mentioned that we'll be using Vieta's formula. So Vieta's formulas gives us basically the relationship between the roots and the coefficient. So x1 plus x2 is going to be negative b over a, which is 5. By the way, I made a video on Vieta's formulas. You can go ahead and check it out. And the product is going to be x1 times x2, which is equal to k. But here's the thing. This gives us the same thing that we got before. Therefore, we're going to end up with x1 being 3. And from here, because that's what we're going to get. And k equals 6 as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe. Take care and bye-bye.